Hi all. This is a descriptive technical deep dive, post the visual context that you saw in terms of how the whole interaction process under the hood works for EKS Anywhere in the previous video. In that, we showed visually how cluster API and the bootstrapping process and everything works. Now, this is going to get even more technical. So if you want to, watch this video, good. Otherwise, you can stay with the visuals. Else, we can go through this actual log that I have captured during the creation of a cluster with the highest verbosity 9, so that it can give us enough information to understand what's going on and how can we relate it to the visual context that we explained in the previous video. Right now, to start with, we can actually observe that I've created already one fresh cluster. So you can see that I have a test cluster. These are the 3 etcd nodes, the 2 worker control plane nodes, and the 2 worker nodes, right? So 7 nodes basically. I can also see them in my kubectl. So etcd won't be seen since they don't run the kubelet, but I can see the 2 workers and the 2 control plane nodes, right? Now, what we will do in this particular narrative is that we will understand. I'm running a script basically to create you don't need to worry about this script as of now, but later in the following subsequent articles, you will see that, there is a script to create the cluster, which is nothing but a wrapper of sorts on the, EKS Anywhere cluster create command. But I run the script and you can see the first things first, actually, what happens. As soon as I run the script, so I'm on the EKS Anywhere admin machine. Okay. The moment I run the script, a read on the bundles manifest happens actually. So EKS Anywhere software needs to know what all it needs to create in order to render the cluster actually, right? And it basically references a release bundle, which is stored, on anywhere-assets.eks.amazon.aws.com. It basically compiles a list of all the components that will be deployed during the cluster creation process, including the bootstrap cluster versions, the cluster API versions, and things like that, right? Now, this release bundle manifest is a part of the, it's a part of the EKS Anywhere installation. The version of EKS Anywhere that you deploy on the EKS Anywhere admin machine will reference a specific bundle actually, right? So if you download this particular YAML, this is what it looks like. And I'll go to the start of it and, I'll just kind of highlight to you. So this is what it basically references, okay? Bundles. And in that, you can see that, there are references to container images for, bootstrap controller. Then you can see that there will be, I'm not going to go through all of them, but I'll show you the heavy or the main parts. For example, once the cluster gets created, the target workload cluster, there will be an execution where CNI has to be deployed, right? So which is the CNI to be deployed? Cilium. What is the the image for that Cilium CNI? So this is the one, right? And likewise, you can look at cluster API, right? Provider for cloud stack or cluster API for other things. Actually, you can see this is the main cluster API controller. So this is the CAPI controller that will run on the bootstrap cluster also and on the target workload cluster if it's a standalone or a management workload cluster, right? So how does it determine which version of the cluster API that should run? So this is the image. Basically, it's on the ECR repository, public ECR of AWS. So you can see that, it points to an image, which is for a cluster API controller. Likewise, it has a lot of things, and I'll try to kind of, explain to you, what happens in the background from an actual execution standpoint. This is also important. For example, when the bootstrap cluster is being created, okay, so the bootstrap cluster is based on a kind cluster, right? Kubernetes and Docker. So you can see that this is what the image that will be used, the kind image actually, for that particular bootstrap cluster. And you can see that the image in reference is using EKS distribution. So the bootstrap cluster, as I said in the visual context, that the bootstrap cluster itself runs EKS distro. So So this is the image that will run for building the Kubernetes in Docker cluster, the Bootstrap cluster. Yeah, and likewise, there are other things. Now take a pause. This is a very heavy lifting or, laundry list of things actually. But I'm just trying to make you understand that the first starting point is to read this bundles manifest and determine what all assets will be in use while the process executes or initiates to create the target workload cluster. Okay, post that, basically, you can see that the first step after reading this is that it creates one CLI tools Docker container. Okay, this is not the temporary Bootstrap clusters Docker container in which the kind cluster is running. This is a CLI tools container that will be used as an exec entry point for creating or executing various other utilities actually, to creating the Bootstrap cluster, to validating certain things and all that. So I'll show it to you visually here. When I look at when that process started and I did Docker PS, this was the first container that got created, and you can see the image that is used as CLI tools, whatever, right? EKS. So it has the CLI tools, has a lot of bundled CLIs, including kind, including Helm, including cluster CTL CLI, kubectl. All those CLI tools are bundled into this particular image so that EKS Anywhere software can do a Docker exec into this and run all those CLI utilities to create whatever is happening as a part of the overall effort actually. So this is the point at which it pulls the Docker image and builds that particular container. Okay, you can see this initializing long running container. And now I will refer to you to this as always container 7507 during the narrative. When I say 7507, it is the CLI tools container basically. It's not anything else. It's where all the CLI utilities are installed and bundled and running as a container. And then you can see that once the container is up, it's basically, EKS Anywhere software is basically doing a remote exec into that Docker container. And then it will run a task inside of that basically. And task name is setup validate. Setup validate is basically I have provided a YAML file to create a cluster. Okay, in which data center configurations are there of vSphere, resource pool definition, network, various folders, the OS template name and all that. So first thing it will do is basically validate all those things. The way it will validate all those things are, it uses a govc utility. Okay, it's a CLI from VMware. It's an API, REST API based CLI that actually you can use manually. Also, you can download govc and you can use those commands to interact with vSphere through an API basis. So govc is already bundled into that CLI tools image actually. Okay, so what it is doing is it's the EKS Anywhere software is doing a remote exec into this 7507 CLI tools container, and then it is trying to validate through govc all the so connected to vSphere, authenticated, then data center validated. So it will validate the data center object that I referenced in the YAML. Does it exist or not? Likewise, network validated, data store is validated, folder, resource pool. You can see all that actually, being validated. Once the validation is complete, basically, it says the vSphere provider setup is valid. Okay, and then it, it does all the things. So it says that task is finished. How did it do that task? Basically, so it basically here EKS Anywhere software running on the admin machine does a remote exec into this self-hosted container, then tries to execute all those commands from within this container, the CLI tools container. Okay, we have not still come to this point actually. Now, once it does validation is complete, then it starts another task, which is create the Bootstrap cluster. Now, what is the Bootstrap cluster? It is nothing but a Docker container running Kubernetes in Docker, and then bootstrapped with EKS distribution to create a Kubernetes control cluster, a temporary Bootstrap cluster that will be further responsible to create the target workload cluster. So you can see that it's creating the Bootstrap cluster by also from the CLI tools container itself actually. So this is from one container, it is trying to create another container actually. So it runs a utility from the 7507 container saying kind, create cluster. So it is basically creating a cluster. Kind is also a CLI utility. Again, it is bundled into the CLI tools container actually, as a kind CTL is there actually. Okay. Now it does create the bootstrap container. So when this command is running, okay, what gets created as a process output is this container. And we saw that, how did it actually determine that this is the image that will run on the bootstrap container is through the release manifest. I showed it to you, right? EKS distro and all that actually, right? So the release manifest, that first step it actually executed had this reference of what version of image will run in this kind container actually, or kind cluster actually. So it basically then is creating this kind container or kind based bootstrap cluster, which is the other Docker container. And then it will do basically some bit of validations on that also. When the kind cluster got created, okay, what will happen is basically a lot of, installations will happen on the bootstrap cluster, as I showed you, right? So the CAPI controller, the cluster API controller, the cert manager, the CAPV controller, which is the the provider specific CAPI controller for vSphere, plus a lot of bootstrap will happen in terms of the various activities that need to happen in terms of CRDs and all that. So by the time this bootstrap cluster gets created, okay, and it says that task finished, okay, task is finished means what? The bootstrap cluster is created. Bootstrap cluster would have also started to communicate, or it has already communicated with vSphere to create the 7 virtual machines that are the part of our EKS Anywhere cluster. And it would have basically bootstrapped those machines also with the OS templates and everything basically. Now there are some pending tasks that need to be done on those, that workload cluster that has been created, that's where it says that the next task is started, which is the workload cluster init process, right? So it says creating new workload cluster. Now it necessarily does not, at this stage build the virtual machines and all that. It's a sequential process though. So you can see that as a part of the new workload creation process, it basically creates, let's say the kind cube config, and then it applies it to the namespace EKS system actually, right? And then it does another bit of validations for, whether the etcd nodes are ready, the control plane is ready, and the, the worker nodes are ready and all that actually, till a point where, so you can see nodes are not ready yet. So there will be a, interim time gap before the control plane, the etcd nodes and the worker nodes, they are in a reconciliation stage, right? Or let's say they are being formed actually, right? Forming stage. And then once the cluster is ready, I mean, those machines, you can see it's trying to get the status of the machines actually for various, node roles. And once that is ready, it will then install the networking, the CNI, the Cilium CNI on the target workload cluster now. This is not being done on the bootstrap cluster. This is being done on the target workload cluster. How does it do that? Again, EKS Anywhere software will actually do a remote exec into the same our CLI tools. You can see that, right? 7507. And then it's trying to generate the Helm template actually for Cilium. Okay. And then it will basically apply that particular template, to the target workload cluster here. Once the Cilium is applied as a CNI, then the default storage class is being applied on the target workload cluster. The default storage class is based on vSphere VSI because this is a vSphere cluster. So, it will basically try to, deploy that. Once that is done, it also then, it tries to evaluate if the EKS system namespace is installed on the target workload cluster. EKS system is the, the controller namespace for running the EKS controller and the CRDs that will go along with EKS, right? So that it can start listening in and kind of, evaluating any changes to the cluster configuration and all that. So it is then creating the EKSA system namespace on the target workload cluster. And then it will basically wait for, the available deployments. So it is now trying to evaluate if the what should I say? Yeah. So you have the cluster API already deployed on Bootstrap cluster. Bootstrap cluster spoke to vSphere. vSphere created the virtual machines. Then basically, the virtual machines were created into a cluster sense with the control plane, worker, and etcd node configurations pushed out. Now is the time to actually move these cluster API resources to the target workload cluster, right? As I explained in the visual for self-management capabilities. So as a part of that, the first step will be basically on the target workload cluster. These CAPI and CAPV components have to be deployed. Okay, so that's what is being done here. And as you move along, you can see that the task name called as workload cluster init has been fulfilled. Okay, now it is basically installing resources on the management cluster. So see, don't get confused between this workload cluster and management cluster. Management cluster is a set of capabilities, right? As I said in the visual context, that management cluster actually represents that namespace of cluster API plus the EKSA system, which give it the ability to manage the workload cluster, which is in this case the standalone workload cluster. So on the same cluster, there's a namespace already created in the preceding steps here. Now there are some CRDs to be installed and some controllers to be installed in that namespace. So that's why it highlights install resources on management cluster. This is no separate management cluster in this case. But in the script that we used to create said that the management cluster was a dedicated management cluster, and this is a workload cluster which is being managed by a dedicated management cluster as a separate cluster. Then the things would have been different actually. Right now, just stay with me. This management cluster is the same as the workload cluster itself. So it's basically installing that particular CRDs on that. So you can see here task start, CAPI management move. So the definitions actually that have been used as resource requests to vSphere, all those are preserved as CAPI CRDs and whatnot, right? So I spoke to you in the preceding video. All those CRDs are basically now being, you can see that it's trying to get the the machines from and all the CRDs from the Bootstrap cluster. It's retrieving that information first from the Bootstrap cluster. How it is doing so? It is actually doing it through the CLI container itself actually, right? And it's trying to basically get the machines and the cluster CRDs and whatnot from the Bootstrap cluster. And then using this cluster CTL utility itself, it is basically doing a move from one cluster to another cluster, basically from the Bootstrap cluster to the target cluster. And we can see many things happening here, but the most important ones I will, waiting for workload cluster machine deployment replicas to be ready after the move, right? So a lot of things are moved, reconciliation happens, and then again a status check happens here actually. And then it counts for the ready machines for the deployment replicas actually, right? Now, once that happens, there is another task that is now, so at this point, you can see the CAPI management move is complete. Now another task is starting here, which is the EKSA components install. Where it is installing, not on the Bootstrap cluster, this is on the target workload cluster itself. What it is installing, a set of CRDs and a set of controllers. I have explained to you what is the EKSA controller and CRD here actually, right? So we can see that the EKS distribution components are being installed. Then the EKSA CRDs are being installed. And then it is applying the YAML file, the actual, the YAML file that we created the cluster with, right? All that is basically, a set of custom resources, right? You can see here, right? We explained to you. So kind is cluster, right? And this is the cluster definition, right? And these are the vSphere machine configurations this is for data center configuration. Sorry, this is the vSphere data center configuration. and vSphere machine configuration for control plane, for etcd, vSphere machine configuration, and lastly the vSphere machine configuration for workload nodes. So it's not like these are not present or it's trying to create. These have already been created, and now it is trying to ensure that this definition is present in the management layer of the target workload cluster, those namespace called as EKS system, so that any changes being requested to this configuration are being tracked and then compared and applied and reconciled. Okay, so it is applying this YAML to that cluster so that these CRDs reside as a part of the EKSA system namespace as CRDs. Okay, so once it does that, it basically then through the 7507 container CLI container, it runs the kubectl and basically it tries to apply these things. Now let's go here. Applying EKSD manifest to the cluster. Okay. So at this point, you can see all those CRDs and the controllers have been installed, and it says that EKSA components install task name has been completed. Where? On the workload cluster. Okay. And then once that is completed, then the ancillary tasks, which necessary in this case, we are not doing GitOps, any other package controllers to be deployed and all that. Those are skipped basically. And then the cluster is fully created. Okay. So everything else is basically ancillary. We don't actually do that. And lastly, it basically logs out from the govc session, which is basically with the vSphere, right? To validate certain things on the vSphere. So you can see the entire process that I kind of explained to you through the visual, as in a PowerPoint slide flow, is now visualized from a actual log perspective. Again, I don't want to get into the details of this too much, but understand, where it is coming from. Plus, I also explained to you what is this release manifest all about, which is the starting point of the entire conversation, right? The other things that I can, we can see here is basically, this is the release. I've highlighted this in the blog as well. So as you get, you can see here, the high level verbose 3 logs look just like this. Okay. Connected to server, authenticated, validations happen, then the control plane validated, then vSphere valid. Then this is where the cluster, new Bootstrap cluster is created. Cluster API gets deployed on Bootstrap cluster. New workload cluster is being created. Networking is installed. Storage class. Then cluster API components get installed on workload cluster. Then the moving of the cluster management. That's the cluster API resources from here to there. The CRDs. Then the EKSA custom components and CRDs. And then finally, it basically results into cluster. So this whole verbose 3 is what I explained to you in verbose 9 actually here. Okay. If you have affinity towards what's happening in terms of the CLI, you would be able to acknowledge. Else, this is a good learning opportunity to see what's happening under the hood, really technically in that sense. Now, other things actually are important is that in the same blog, I have also given as a part of this release bundle, there are some artifacts also being used, right? So I've just highlighted here, and I've shown it to you in the previous video also. Mainly, the artifacts which are actually used, right? And I've explained it to you in the previous video, but just want to highlight in this video too, that all these, the release bundle combined with, when this gets executed, these are the actual, that release manifest gets translated into these particular components in this form. And you can see that this is a part of the Go routine called as artifacts.go under V1 alpha of EKS Anywhere release actually, right? So this is the translation of that release bundle into the actual software routine. Other things that are important is the build tooling. I've already spoken to you about that. And if you want to actually check out, what's happening, on the EKS distro. Now, this is the actual distribution of Kubernetes that gets deployed on the Bootstrap as well as the target workload clusters. You can click on this link and see basically here, So you can look at this releases as in what gets what is a part of this particular individual EKSD distributions. So I can click on maybe version 1.22, for example, this one, and you can see the release manifest for this is not for EKS Anywhere. This is for EKS distro now. Okay, so you can see within the EKS distribution, the core Kubernetes will be running. Okay, and other things that get actually bundled into that core Kubernetes are all these kind of components like the CSI snapshotter or the let's say external attacher, provisioner, okay, yeah, metric server. So yeah, this is what about 19 odd containers is what I would say, or components which make up the Kubernetes distribution called EKS distro. So with that, I think I will come to the close of this video. Again, it's been a long translation of actually what goes on under the hood, but hopefully, it gives you a perspective that you can experiment, in case you are trying to build your own EKSA clusters. You can actually, similarly, you can run a command with the verbose 9, and then, you can just validate this. So thanks a lot. Hope you gained some bit of knowledge. Thank you. Cheers.